To everyone who's joined since first greeted. My name is Sean McPhee, and this is Accessibility for the Rest of Us, what everyone needs to know to build accessible products. This is an important topic that doesn't always get the love that it deserves, so thank you all for tuning in. Today, we will answer the questions, what accessibility is and why it is important. Then we'll look at the accessibility standards and their core principles. We will finish with common accessibility tasks and best practices. And if there's time, we'll have some questions at the end. But before we dive in, let me take a moment to introduce myself. I'm a front-end engineer at niche.com here in Pittsburgh, PA. At Niche, we work to make researching and enrolling in schools easy, transparent, and free. Before that, I was a software engineer for a financial tech company in Atlanta. And before that, I was a public school teacher. Most importantly, I'm a husband, a father of one with another on the way, and a Christian. If you're interested in any of these things, how I transitioned from being a teacher to a developer, I'm happy to connect after the talk. Now, you may have noticed something missing from that list, and that's that I am not an accessibility expert. But before anyone signs out of this talk and moves on to the next one, that's kind of the point. Because you don't have to be an expert to build accessible products. Now, there will be scenarios when you should seek an accessibility expert, and we'll look at that a little bit later. But the lion's share of accessibility work is something that every developer can and should do. So the focus of this talk is on what everyone can do to make accessible products. And to begin, let's answer the question, what is accessibility? Accessibility is the practice of making products and services that can be accessed by everyone. It's about making your product, whether that's a mobile app, a web-based application, or a website, available to as many people as possible. Oftentimes, you'll hear accessibility included in discussions with usability, and you can think of these as complementary disciplines. But we need to include accessibility in the discussion because for a product to truly be usable, it first needs to be accessible. For an illustration, think of a basic smartphone like a Moto G. It's a perfectly functional, middle-of-the-road device that you might use for Android testing. Now imagine we took this phone and put it on the top of a mountain. The phone didn't change. It's still usable, but I know I can't climb up there. It's now totally inaccessible to me. And that might sound like a contrived example, because it is, but maybe we're not dealing with a literal mountain, but a different type of obstacle. See, it doesn't matter how user-friendly the products are at the bottom of that escalator. She can't get there. They're totally inaccessible to her. So when we talk about accessibility, we need to talk about disabilities, because these are the neighbors we are most likely to leave behind when we ignore accessibility. According to the US law, disabilities are defined as a physical or mental impairment that substantially limits one or more major life activities of such individual. These are folks who have it harder in life as a result of these impairments. And broadly speaking, we can categorize these into the following categories. Visual, which is an impairment in the optical system. Hearing, in the auditory system. Motor, an impairment in how the body moves. And cognitive, which is an impairment in the way that the brain functions. And I'm sure many of you can think of examples in your lives of individuals with disabilities in each category. But it's also important to remember that a disability can be permanent or temporary. Some examples of temporary disability are eye surgery, or a ruptured eardrum, a sprained ankle, a minor concussion, even holding a struggling child. All of these are temporary things that affect the way that you go about your normal tasks. When you include temporary impairments, we see that disability affects everyone. Now, it can be tempting to put accessibility into a box of helping people who look like they have a disability, but we really need to resist that. Instead, we want to expand our definition of accessibility to be making products that work for everyone. Accessibility is about making a great product for your users, regardless of the situation that they are in. So with that definition in mind, let's look at some specific reasons why accessibility matters. I could talk about this for a long time, So I'm going to focus on 3 reasons: quality, reach, and compliance. First is accessible products are better than their competition. And researchers have noted this, writing, solutions designed to benefit vulnerable groups, such as the disabled, often end up benefiting all of society. An accessible product is better for all people, regardless of their ability level. This observation that accessibility benefits everyone is called the curb cut effect. It might not be immediately apparent, but the curb, that step between the sidewalk and the street, can be an accessibility barrier to many people. I encounter this when I'm pushing my son in his stroller. Even a little curb can cause an issue, and I'm able to pick him up if necessary. The curb cut is that portion of the sidewalk that drops down to street level. With a curb cut, many more people can safely move down to the street. And they also provide a clear landmark and transition for other folks, so other folks can safely cross the street. But the curb cut effect extends beyond the sidewalk. One of my favorite examples comes from the world of industrial design. There was an industrial designer who noticed that his wife was having trouble peeling potatoes. Her arthritis made it difficult to hold the flimsy metal peeler. In search for a solution for her, the designer prototyped a new peeler with a large rubber handle that fit nicely into your palm. With this new peeler, his wife could comfortably peel vegetables despite her arthritis. But the design wasn't just better for her, it was better for everyone. The guy who designed it, he loved it too. It was so good that he founded a company, OXO, around his accessible innovation. The OXO peeler was the best on the market because it was accessible. Nowadays, you'll be hard-pressed to find a peeler without a big rubber grip. Which brings us to our second reason, which is that accessible products reach more users. By focusing on accessibility, you can increase the potential number of users for your application. And the increase is significant because, according to the CDC, 1 in 4 adults is living with a disability. That's a huge section of the population. And to break that down a little bit, 13.7% of adults have a motor or mobility disability, 10.8% have a cognitive disability, 5.8% have a hearing, and 4.6% have a vision disability. Links to this resource and all of the references are available at the end of the presentation or in the link that I posted. So if your product is accessible to those neighbors, you will significantly increase your potential user base. And remember, anyone could have a temporary disability. Broken arms, sore throat, concussion, eye surgery, these could strike at any time. So by building an accessible product, you will invite more users and keep them there regardless of what happens tomorrow. And the final reason that accessibility matters is that an accessible products comply with the law. Accessibility is a legal requirement in most countries. Here in the United States, that law is called the Americans with Disabilities Act of 1990, or ADA. The goal of the ADA is to eliminate discrimination against individuals with disabilities. And that's a real aspirational goal. To meet it, the ADA requires businesses to accommodate everyone, regardless of ability. That's why curb cuts and lifts started showing up in workplaces, because the law required it. But the ADA extends to online businesses too. Domino's Pizza had an interactive pizza builder that was inaccessible to keyboard users. Someone sued, arguing that it illegally discriminated against people with disabilities. In 2019, the Ninth Circuit Court ruled that the online pizza builder was bound by ADA. Domino's appealed the decision to the Supreme Court, but they declined the case, so the lower court ruling stands. In that case and in other cases, the legal precedent has been set. Mobile apps, web applications, and websites must be accessible to comply with the law. We looked at 3 reasons why accessibility matters, but let's sum it all up. Accessible products are better than the competition, they reach more users, and they comply with the law. Or to put it even more succinctly, accessibility is a good idea. Now that we have the goal of building an accessible product, we need to turn to accessibility standards. And the official standards for web accessibility are the Web Content Accessibility Guidelines, or WCAG. Just as the name suggests, these are a set of rules for creating accessible products online. The WCAG is organized by the W3C, which is the same group that writes other web standards, and dates back to 1999 with the release of version 1.0. And as you can remember, or imagine if you're a little bit younger, the web was a very different place back in the late 90s. So in 2008, they updated the WCAG to version 2.0. Then, 10 years later, they must have realized that their versioning system wasn't working, so they released version 2.1 in 2018. The working draft for version 2.2 is underway, but for this talk, I'll be referencing the latest release, version 2.1. The WCAG takes all of their rules and organizes them by principle, guideline, and criterion, and that goes from most general to most specific. Each standard is named with the following format: principle.guideline.criterion. For example, 2.5.3, principle 2, guideline 5, criterion 3. Each standard is given a compliance level. Level A is basic compliance with the WCAG, AA is better compliance, and AAA is the best. As a team, you'll need to decide on a specific goal for your application, but it's generally recommended to aim for AA, and you can think of AAA as aspirational. With the structure and levels in mind, let's look at some rules from the WCAG. Here's an actual one from the WCAG 2.1 called use of color. We can see how it's organized into principle, guideline, and criteria. Up here, 1.4.1. That's principle 1, guideline 4, and criterion 1. It has a level A, which means it's basic compliance, and the description is here. Color is not used as the only visual means of conveying information, indicating an action, prompting a response, or distinguishing a visual element. Next to that, there are some helpful links off to the side: understanding use of color, how to meet use of color. And finally, there's this nice call-out note at the bottom with additional information. Let's compare that to another standard, 2.1 keyboard. Now we can see that the principle has changed, which means we're in a different aspect of accessibility. This too is level A, which is basic compliance. And this criterion states that all functionality of content is operable through a keyboard interface. This is what Domino's got in trouble for. Next to that, we have the same helpful links and a note at the bottom. The WCAG takes all of these rules and divides them into 4 main principles: perceivable, operable, understandable, and robust. Let's take a look at each of the core principles in more depth. The first being perceivable. And this quote is from the WCAG. Information and user interface components must be presentable to users in ways they can perceive. I want you to think for a moment, how do you perceive an application or website? For me, perception is visual. I see the images, text, and buttons that are presented. But what about neighbors with low vision, or no vision, or different vision? These all perceive the world differently. Sometimes information is presented as an audio clip. I can perceive that with my ears, but others cannot. The perceivable principle focuses on presenting all important content in ways that the user can consume. Some examples of this are text alternatives. All textual information on a page needs to have a corresponding descriptions. A common example of this is alternate text for images. The next guideline is time-based media. Provide alternatives for media like audio and video only content. Captions for podcasts and videos fall into this guideline. Next, adaptable. Content needs to be able to be presented in different ways without losing information. If a user switches their phone to landscape, for example, they should still be able to see everything. And last, distinguishable. Make it easier for users to see and hear content by separating it from the background. Color contrast is a big criterion here. The perceivable principle can ensure that a user can detect the interface and content. The next principle is operable. User interface components and navigation must be operable. Some people use a mouse to interact with their computers, their thumb on a smartphone, a keyboard, eye tracking, or other assistive technology. To accommodate all users, we need to ensure that our apps can be used with multiple forms of interaction. And the big guideline here is keyboard accessibility. All functionality needs to be available from a keyboard. This entails using the right HTML elements and managing focus appropriately. The next guideline is enough time. Give users enough time to read and use content. This guideline comes up when creating a vanishing notification that may pop up at the bottom of the screen or the top of the screen. Next, seizures and physical reactions. Perhaps this goes without saying, but don't design content in a way that is known to trigger these effects in people. Next, navigable. Provide ways to help users navigate, find content, and determine where they are. Well-structured pages, meaningful page titles, and descriptive links are all part of this. And last, input modalities. Make it easier for the users to operate the product through various input methods. A growing component of this guideline is specifications for the target size for interactive elements so that people can use their thumb to tap on a smaller screen. The operable principle ensures that users are able to interact with the interface effectively. The next principle is understandable. Information and the operation of user interface must be understandable. When a user lands on your page or opens your app, they should be able to figure out where they are and what is going on. A user needs to be able to read the content, scan the elements, and know how to interact with the web page. The WCAG 2.1 has 3 guidelines for this. First is readable. Make text content readable and understandable. This involves both setting the language for the page and using the right word choice. Next, predictable. Make web pages appear and operate in predictable ways. Stick to the standard look and functionality of web elements and only deviate slightly when absolutely necessary. And last, input assistance. Help users avoid and correct mistakes. Give the user as much information up front with labels and descriptive text, and then provide helpful error text when necessary. The understandable principle ensures that users can comprehend the interface and how to use it correctly. And the final principle is robust. And this is probably the most helpful description from the WCAG. Content must be robust enough that it can be interpreted by a wide variety of user agents, including assistive technologies. This principle only has one guideline: compatible. Maximize compatibility with current and future user agents, including assistive technologies. This includes using valid HTML and setting a proper name, role, and value for interface components. It's not mentioned in the WCAG specifically, but a major component of this principle is cross-device and cross-browser testing. Your product should function on all major browsers and/or operating systems. The robust principle ensures that users will be able to access your content from anywhere. And altogether, the WCAG's principles ensure that users are able to access, perceive, understand, and use a product. Now, it's a challenge for sure, but the work is something that every developer can do. And in practice, meeting the WCAG's criteria involves some common tasks. The first is follow the W3C's lead. They're the ones who write the WCAG. They're the accessibility experts. So get familiar with their resources and reference their examples. When I'm building an interactive component, I first do a search to see if the W3C has an example I can copy. There is no reason to reinvent the wheel, particularly when it comes to accessible components. Here's an example for a collapsible drop-down list by the W3C. It has all the expected keyboard support. It has notes that you need to follow. It even has a sample element that you can interact with to see just how this component is expected to work. If you need to build something from scratch, definitely follow their lead. The next common task is color. This is a component of the perceivable and understandable principles. Accessible colors have sufficient contrast between the background and foreground elements, and they complement, but don't replace content. When you do an automated accessibility audit, these are the issues that will pop up most often. And to catch these, you can use tools like the browser's contrast checker. Here are screenshots from Chrome and Firefox where the contrast ratio is insufficient at github.com. Here it is on Chrome, and here it is on Firefox. Get in the habit of checking color combinations during your design and development process. Resolving these are an easy win that can greatly reduce the number of accessibility errors in your product. The next common task is using the best, most semantic HTML for the job. This is a part of the perceivable, operable, and robust principles. Some common tasks are using links and buttons appropriately, and then using the best HTML5 element for the given situation. Let's take a look at a few code samples. Here we have an image with an on-click attribute. This is an issue because it can't be used by keyboard users. Instead, wrap in interactive elements with a button, which has a bunch of accessibility features built in. If the default styling of buttons is a turnoff, you can reset them by default in your CSS or with a specific class. After buttons is overuse of non-semantic HTML. We just look at this code here. We've got a div, wrapping a div with another div, and it's just divs all the way down. These are tempting to reach for because they don't have any browser styles, but they also don't have any meaning for assistive technologies to parse. Instead, use descriptive elements for every situation. Here we replace the wrapping element with a main and the text with h1 and p tags. The container could remain a div because it's only used for styling purposes. Take the time and reach for the best element. The next task is labeling. This is a core part of the perceivable, operable, and understandable principles. And this involves adding alternate text for all graphics, labeling your forms and form elements correctly, using buttons and links with meaningful content, and using ARIA carefully. That can be as easy as adding an alt attribute to your images. This should include a succinct description without words like image of or graphic. For form elements, avoid using placeholders as labels. They may look sufficient, but they are inaccessible to some assistive technology. Plus, they disappear when they start typing, which is just frustrating for everybody. Instead, use a label element or set the label directly on the input. Everyone will benefit from clearly labeled form fields. The next common task is page structure. This is a part of the perceivable, operable, and understandable principles. Use landmarks like main, header, and footer with appropriate roles, follow the heading order, and list elements sequentially in the DOM. This will involve taking code like this with unordered headings. Here we have H1, H6, and then further down in H3. Decisions like this are usually for styling purposes. And then we have this side panel, which is just right in the middle of the main content. So it's probably done that because it would make it easier to position it with CSS. You can enforce page structure by ordering heading elements appropriately. Here we have H1 followed by H2. Moving the side panel out of the main content. Here we have it down beside the main, and using more semantic tags. So here I used section and article as well. Little changes like this make it a lot easier for assistive technology to parse the DOM and users to navigate the content. The next task is focus management. This is part of the operable principle and is probably the trickiest task in this list. To do this correctly, you'll need to transfer focus between elements, store references to previously used interfaces, and trap focus when necessary. There are a few steps to manage focus correctly, but a basic example is opening and closing an interface like a modal. Here we have a Boolean value for the modal state and two toggle functions to open and to close. I've removed the render and cleanup logic just for simplicity. This alone won't work for keyboard users. They'll be stuck focused on the element that triggered the modal and won't be able to access the content within the modal. To do that, you'll have to store a reference to the trigger as well. So we created another variable with the trigger reference. On open, when we're toggling the modal state, we also store the trigger in our trigger reference variable. And then when we close the modal, we can then focus that trigger reference and then reset it for the next time the modal needs to open. This will allow a user to move into the modal when it opens and out when it closes. I like to picture the focus on the screen moving in and out of interactive elements, and that helps me prioritize focus management. And the last common task is advocating for the user. This is the least technical task, but maybe the most important. You need to talk about accessibility on your team without groans or eye rolls. We looked earlier at why accessibility matters. You can take some of those reasons back to your team if necessary. And remember to try to be the voice of whoever is not in the room. You probably don't have a member of every team at work with a major disability. And that puts the onus on all of those present to advocate for our neighbors. All this can be intimidating, but a good place to start is, if you see something, say something. These problems are solvable. We just need to be on the lookout for them. And when you see one, say something. These common tasks span from easy to complex, but no more so than the other crazy cool stuff that we do as developers. If you can spin up a microservice or scale containerized applications or architect a global application state or set up Webpack, then you can make an accessible product. I believe in you. To get us all there, let's look at some best practices. These are things that you and your team can do to help build an accessible product for everyone. First, prioritize accessibility. It's easier, cheaper, and quicker to prioritize accessibility in the beginning. So take the time to do things correctly up front instead of rebuilding everything in the end. If your company is considering a design system, that is a perfect opportunity to start with accessible first assets and components. There are some component libraries that you can use that focus on accessibility. I've selected two options here from the React ecosystem, Reach UI and Chakra UI. But regardless of the framework that you use, or if you don't use a framework, there's good examples of accessibility-focused components for you to add to your applications. Once you prioritize accessibility, add accessibility targets and acceptance criteria. Decide on the version of the WCAG that you are going to use and the level of compliance that you want. Then add accessibility to the acceptance criteria for all of your work. This might look like a checklist of keyboard tasks that must function for a new interactive element. User story. As a user, I want a drop-down menu in the header so that I can log into my account on any page. Acceptance criteria. When the account button is selected, focus moves to the first item in the dropdown. Focus is trapped within the dropdown, and escape key closes the dropdown. Once you have those targets and criteria, you need to audit your code. We need to check if our code is accessible with the same frequency that we check everything else. And there are two types of auditing, automated and manual. First, automated audits. These are the processes that will scan your code for accessibility issues. This type of auditing is good and fast. We can get near instantaneous feedback in our editor or console whenever there is a detectable accessibility issue. Some tools to help are JSX, A11Y, and ReactX, and Vuex. These are all NPM packages that will scan your code for issues. Svelte, which is a front-end JS library that has accessibility checks built into its compiler, and will highlight those issues out of the box. So you can't even get your code to run if it has these detectable accessibility issues. Next, Axe and Wave are browser extensions that will run audits on any web page. And I use these all the time when developing. And Chrome Lighthouse, which is a Chrome feature that includes accessibility audits right in the DevTools. This uses the same engine under the hood as the Axe extension, but it's helpful to see how Google implements it as well. These are good, fast, and can help you catch a lot of errors, but they're not foolproof. Manuel Mantusevich wrote an article in 2019 about how to get a perfect Lighthouse accessibility score with a totally inaccessible website. It's an interesting read and helps illustrate how automated accessibility audits can only get us so far. They need to be complemented with manual audits. And that means a person sitting down with a computer and completing the exercise. Just like all manual processes, this is better when it's done correctly, but it's very time consuming. To do manual audits, you need a keyboard and a screen reader. If you have the results from your automated tests, that can help give you a good place to start. And if all that sounds intimidating to you, take heart. There are resources online to help. Google Developers has an article written by Rob Dodson, an accessibility expert, on how to do an accessibility review. This is a great resource to check out. I found a few other examples like this that are included in the references at the end of the presentation. If your company would prefer to outsource the manual auditing process to really bring in the experts, you can do that too. WebAIM and DQ are two examples of companies that specialize in accessibility tools, training, and services. They make the Wave and Axe browser extensions that I mentioned earlier. Whether you do your audits in-house or outsource them, just make sure that you are doing them. After auditing, move on to testing new features. All new features on your product should be tested for accessibility before they go into production. Just like auditing, there are automated and manual components to this. Automated testing, these are end-to-end and unit tests that check specifically for accessibility. This could be some things like writing selectors based on labels instead of classes, checking for focus management, verifying that the header order is preserved. And these are better than automated tests, audits because they can be smarter. So while the initial time investment is higher, they give you lasting confidence that your code works as expected for your users. To do this, you'll want to use tools like Testing Library, which focuses on getting your tests as close to the actual DOM as possible. They have helpers for all the major libraries too. And with that, Cypress, Protractor, and Nightwatch are all end-to-end testing libraries that run in an actual browser. They can navigate through tasks super fast and verify that everything works as expected for both mouse and keyboard users. These are great and can give us real confidence, but they need to go along with manual testing. And this is just like manual auditing, but for the new feature. Manual testing is better when done correctly, but time consuming. So guard that time in your sprint. After testing new features for accessibility, you can build automated checks into your CI/CD process. Releases should be blocked by inaccessibility, and you can quote me on that. And if you have automated tests, they can be included as checks into your typical build process. If we can stop a release for a linting error, which I know that we do at Niche, we can certainly stop one for accessibility. With that in place, you can move on to a no new errors pledge. And this is a decision that you make as a team to commit to no new accessibility errors. So wherever your product is on the accessibility spectrum, if it's great or it's got a lot of work, a pledge like this will ensure that it doesn't get any worse. This requires audits of existing code and testing of new features, which are both best practices. Plus, it gets everyone thinking and talking about accessibility. And then push fixes every sprint. They can be big tasks if you have time or little fixes, but get one pull request deployed every sprint and your app will make real improvements over time. I read a recommendation for Accessibility Deploy Fridays, which is an effort to push an accessibility fix every week. Whatever the cadence works for you, get those fixes merged and take one step closer to the goal of an accessible product. And finally, advocate. If you see something, say something. Try to be the voice of whoever is not in the room and advocate for hiring individuals with disabilities. The more diverse our teams are, the easier it is to build a strong product that works for everybody. To wrap up, I tried to order these practices sequentially, but you can pick any of them and add them to your team's process. But there isn't one thing that you can do that will make all of your accessibility problems go away. I wish it were so, but it's more nuanced than that. Instead, this is a multi-pronged approach that will slowly make your product more accessible over time. They're all just another step on the journey to building accessible products. We covered a lot of ground in this talk. I know my voice is getting tired. We defined accessibility as the practice of making products that work for everyone. We learned how accessible products are better than their competition, reach more users, and comply with the law. We were introduced to the WCAG, the Web Content Accessibility Guidelines, and how they're organized. We looked at the WCAG's 4 principles: perceivability, operability, understandability, and robust. And we went over some common accessibility tasks with code examples. And finally, we ended with some best practices like prioritization, testing, and advocacy. Now, I want to end this talk with 2 things. First, a challenge. Choose 2 of the best practices and add them to your team's process. If we can all commit to that, then we're on our way to building a more accessible web. And second, a reminder, you don't have to be an expert. Everyone can make accessible products. So get out there and advocate for your users. Thank you everyone for your time. The outline and references for this talk are available on my website, seanmcp.com. I've also added a link here in the session. If you have any questions or comments, we can try and answer them now, or you can hit me up on Twitter at snmcp or email sean@seanmcp.com. So I'm going to go from the top down. Joel O'Keefe says, I used to be a member of the Society for Technical Communication. One guideline I remember is Section 508 of the Rehabilitation Act, which mandates that user interfaces don't present challenges for colorblind users. Are you familiar with such compliance rules? I know that depending on the work that you do and the sector that you're in, there might be additional restrictions with Section 508. And that nonprofit groups might have different rules that apply to them specifically. But in terms of your exact legal compliance, I would definitely consult a lawyer because the general precedence is that companies and online services are bound by ADA. Next, April Rack asks, what are your thoughts on color blindness? A lot of software rely on colors, red and green to show states with no other visible ways to see a state change. So my thoughts on color blindness is that it's poorly named, but still something that affects a number of people. And one of the WCAG guidelines is specifically don't use color alone to signify anything important to the user for that exact reason. So if you have a green success state, combine that with an icon or some type of text that says success. Similarly with a red failure state or a warning state, also have something other than color to signify that something has gone wrong. Next, Gareth Warren. Okay, jumping in and helping out. I appreciate that. Different values of green and red, for example, will show up differently when seen as grayscale based on their luminosity and can still stand out from each other. You can also choose not to focus on using colors as common. Yeah. So I think then that's why thinking of it as color blindness is probably unhelpful. Instead, just making sure that there's a way to distinguish without relying solely on color. Wonderful. It's great to see some support from my friends at Niche. Represent. If we don't have any other questions, I might just end here. Yeah, so Gareth Warren asks, how would you recommend on making UI more usable for people with motion disabilities, such as tremors, etc.? So for an individual with tremors, the physical interaction with the keyboard is going to be the most difficult part. So if you imagine someone trying to use a mouse with a tremor, it's going to be very difficult for them to click on a small target. And one of the WCAG criterion is recommendations for target size to make sure that it's large enough. You can think if there's a really small button and your hand shakes a little bit, trying to click that small button would be a bit of a challenge, even if it's just with your thumb. So making sure that all buttons are a sufficiently large size. And I think the recommendation is currently 44 pixels. And on mobile, I think it's actually 48 DPI. There's some slight different recommendations for that. But definitely make sure that the space to interact is as big as manageable so that those users can use it well. My pleasure. All right, I'm imagining here that I just finished giving my talk. We're in a small conference room. Everyone's giving me like polite applause. And I know now's the time I can wrap up and leave the stage. So thank you everyone for attending. I really appreciated it. And please do connect and let's continue this conversation here in the Pittsburgh tech scene. All right, later.